Hi, everybody. Welcome to the Ops Engineering Showcase for October 5th. Today, we will have Fabio share with us, and I will let him take it from here.
Thank you. So I'm going to share the screen. So today what we're going to talk about is something I've been doing on the side, and decided to open a proposal for GitLab engineers to discuss how can we possibly split the GitLab monoliths into components to improve isolations between components and a series of things like that this proposal is aiming to solve. But first of all, just link here like the actual proposal if anybody wants to look into in details, and reporting some of the problems that we have. Like most of us are agreeing on having these problems, and that there is some discussions currently in how can we get there and how we can solve some of these problems. So there's problems from different angles, like from engineering, for example, like onboarding engineers sometimes gets quite slow because there's like a lot to take on the code base and to understand and be familiar with. So it's also impossible for even experts sometimes to build like a mental map of what is happening in the application because just of the complexity and everything that is going on. And sometimes we even make changes and can have like a far-reaching and even catastrophic repercussions. In other sides, parts of the monolith that were kind of unexpected on the moment of the implementation, and then so. And all the other problems related to also architecture, the fact that we have no clear domain structure, like it's hard sometimes to understand who owns certain parts of the code, or in terms of who is who owns the stewardship of that code, like the vision, how this feature or this part of the code should evolve. And sometimes it's a bit easier with well understood features, but sometimes gets very unclear with certain things like projects or user, and or there are cross-cutting concerns, and it gets very, very difficult. And we have a lot of issues with unorganized code, and especially in the lib folder. And the Rails doesn't provide like good boundaries by default, and everything lives under the same. Everything is public for Rails, and you can reference any constants. And this it's very powerful in a way, but at the same time, and especially if you want to get started very quickly with Rails, but as the complexity of the application grows, it gets harder to maintain a code base that allows you to reference anything you want, and because it basically allows you to couple things in different directions and build like spaghetti dependencies. And also from a productivity perspective, our CI takes longer and longer to build and test. It can be overwhelming from wider community to contribute to our code base, and there's no way to test like partially the code base because of this amount of coupling that is in the code base. So ideal scenario, like if you want to look at our coupling, what's good and bad coupling, we know that loose coupling, high cohesion is like the ideal scenario, where we have two different parts of the code base that are interacting with the well-defined API or well-defined interface, and all the communication goes through that. So this allows one part of the application to even be completely refactored, and without worrying too much about how this is being used, as long as the contracts are being are still being satisfied. But in the opposite scenarios, where everything is coupled with everything, it becomes very hard sometimes to understand if I change this code, how everything else is going to be affected. And so from a dependency perspective, we could have ideally non-cyclical dependencies, where we know, for example, the web layer will depend on things like merge requests and CI, but then CI in turns depends on repositories. The repositories depends on the platform, but there's no circular dependencies where merge request depends on CI, but CI also depends on merge request, and so it then can become difficult to understand the repercussion of changes, and also to understand like what do I need to understand in order to make a change in a specific part of the application. So today we have a tool that was developed by Shopify, and it's called Packwork, that allows us actually to break down monolith into packages, and it's a very powerful tool. We're going to see a demo of that. So I think this tool could help. Basically, I put that into this proposal as being extremely useful into us being able to split a part of the application into components, or even if we could just extract one single component. And how can we ensure that this, like some implementation details of this component are not leaked outside, or how can we ensure that only specific parts of the application can communicate with this component? And so without this tool, we wouldn't be able to do anything like that. And what is the good part, the good side of this is that Packwork is like a static analyzer. So even if we make some mistakes into defining dependencies or allowing certain dependencies from actually exist, nothing breaks on production. It's a simple static analyzer that can be used in CI to guide developers, understanding the complexity of the code base and how to make design decisions. We're gonna jump. So I have prepared like a POC. I actually worked on several POCs to try to understand what is the approach we could take for splitting the code base into multiple components. And so this is what I linked here is like the third approach, a third attempt to do that. And so far it's the best I've found. So when we break a monolith into different components, we don't want to be dealing with a lot of violations and things to fix by moving files around. Ideally, we would like to first start moving files and nothing should actually break. And then as we move files, we can start to introduce some constraints into the application, like saying, okay, if I move a file from into this directory, I don't want external code to be referencing it. So we can actually start adding some of these constraints like slowly. So you can have a look at this POC if you want to look at more details, but today primarily I'm going to focus on what Packwork is and what has the files and features, and how can this be used in GitLab code base to improve the design. So in this here, like I have, this is basically code checked out from the POC that I linked earlier, and what I created are inside the main GitLab folder. I created like a package YAML file that describes basically what are. I'm going to get into this like in a second, but I created basically this package YAML file, which is supposed to be the main container of the application. And the whole entire application for Packwork is considered as to be like a package, and it has like a reason for that we get in a second. And then I created this a folder called components/CI, which is supposed to be where we might want to move CI files. And this could be eventually, we might have multiple of these directories, like within components, we might have, I don't know, something like merge requests, projects, and issues, and each defining areas of the monolith. So I create a component CI, and by putting in a package YAML, we can now decide define some rules for any files that are defined inside this directory. So if we look at what is inside this CI, at the moment I didn't move much of the files. I wanted just to test what is like the minimal step we could do it. So I moved some files that are basically the libconfig CI, lib GitLab CI config, and it's basically, and with all, basically this is like how we handle the YAML file for CI pipelines. But doesn't matter as much. It's more like there is like a small components of CI application that is being extracted and moved into CI component. Now there's a lot of code from CI that still sits outside of this component directory, but there's basically two main constants with like one is like GitLab CI config that has been moved inside it with a lot of sub components of it, collaborators like CI / config / something else, and another constant that has been moved inside this component is CI pipeline. So for now I'm just commenting this out, but what I want to show is that I've now moved some files, and I can get Packwork to tell me whether there is any violations now from the code base. So if I comment this out, basically we are telling Packwork, I don't want to enforce any sort of privacy. So any files that are inside CI components are always public. So that means anything outside CI component can reference CI constants. But if I want to force now the CI config to be private, so actually this seems to be more like this is a private component or private. I'm getting a bit confused with component. Like I don't want to overuse that. A private collaborator of CI. So I don't want actually this to be referenced outside because it's some kind of implementation details. And if we run this, we have a command called Packwork update. Actually, let's do Packwork checks. And this will tell us whether there are any violations. Actually, bundle exec. So Packwork is inspecting 14,000 files. It's pretty fast because there is like this caching enabled. And we could even use this caching even on CI, like if we want to. So, but at the moment it tells me there's no offense detected because I've actually kind of whitelisted some of those. If we look at deprecated references, so there is this other command called actually, let me do one thing. I'm going to remove this. References. I'm going to remove this file. If I run this command again, it will tell me basically all the places in the application where it is being referenced. Why this is important? Because I would like to isolate this part of the code base. I would like that to be private to CI. I don't want anything else to reference it. And now, yeah, we can see there's some errors. It tells us like actually very helpful messages. So for example, we have this in this file, we are referencing a constant GitLab CI config entry needs wherever something is inside this constant, and it's telling me exactly where this is being used. If I look at that, actually tells us like, okay, this part is referencing that constant. This is not so bad because still under CI namespace, and eventually we would like to move all these under the CI component. But if there is anything that is outside it, then we would like to be able to know in advance and fix it. So I can do the similar thing with, now instead of doing with GitLab config, I want to do with pipeline, for example. This is a much more popular constant. So I'm going to show like what are the things we can actually do to solve this problem. So another thing, while we let this running, other things that we can configure for this specific package. This is like a package metadata specifically for CI a component. We can tell Packwork to enforce dependencies. And that basically says if anything from outside CI is referencing constant code like from within CI, we want that to be explicitly defined. And this is why, for example, in the main application package, which is on this file over here, we are specifying dependencies. So this main application, the code, anything that runs in the main application depends on CI component. And we can see here that as we add more and more components, if we extract the components out, we can have components here like /merge requests and etc. So it means that the entire application needs to use these components. And this is basically, it's defined by saying, I want to enforce dependencies. This describes what privacy policies we want to enforce. Like we want to always enforce everything. We want to enforce privacy for specific constants. And as again, here can specify the dependencies. And this is pointing up to the main application, just because CI code at the moment, it's only just a bunch of classes and it can't work fully in isolation. So it has to reference some code outside of CI. That's why there's at the moment this kind of circular dependency where CI needs to know the main application and the main application is to know CI. But as we create more and more components, we should move from this kind of circular dependencies into something more like this, where we have a merge request component that explicitly depends on CI, which then explicitly depends on repositories, but then merge request could depend also on repositories. So this kind of dependency map it's a lot more clear rather than having circular dependencies. Circular dependencies is unavoidable at the beginning just because we are extracting a tiny part of the application. And also we can define any other sort of metadata we want for a specific package, which could be, I just put here like stewards, like what are the teams or the or individuals or kind of experts or responsible for this component. So it could be like groups, or it could be specific people, or Slack channel. It can be anything. It can be README links, or any kind of a metadata information we can put here that we can also reuse in an automated fashion as well. So this is kind of a nice thing to be added there. So as we see here now with CI pipeline I ran earlier, so now I'm enforcing privacy for CI pipeline. I get a lot of offenses, 122. So these 122 places where we are referencing CI pipeline, and in theory should not be used because I'm actually forcing this. So one thing I can do is now, Packwork provides me a command to register all the current violations. So in a way to say, okay, I know that I have like 122 offenses, but I want to work on these offenses bit by bit. I don't want to block CI at the moment. So I want to record this, move on, and then I can work off this list like later on, similar to how Rubocop to-do files work. So this command called update deprecation. What this is going to do is going to create a file and record all these violations in there. And we can have a look at those specifically. And we're going to have a quick example of how we could solve certain bad patterns. So deprecated dependency, deprecated references has been created. Now here we have a file that was automatically generated by Packwork and tells us like, okay, within for CI component, we have this constant and we have violation of privacy in these files. For example, there's some files, for example, if we look at like usage data, if you're familiar with, for example, usage data, usage data. If we look at CI pipelines, you see it's actually referenced several times in this file. Maybe for this file is okay because usage data, it's more like some analytic tool that it might be acceptable to reference CI pipeline directly as a model, but maybe, you know, so we can leave it this here in this list and basically always disable and say, okay, this is acceptable. Maybe other files are unacceptable that we are referencing directly pipeline, and we should kind of start to decouple things. So, and we have at the moment here some files you can notice they are nested within CI. And this is currently because I only extracted a small part of CI code base. So there is other CI related files that are referencing CI pipeline. But eventually in ideal world, once we move all CI files into a component, those will be automatically resolved because they are all files that belong to the same component, and there should not be any kind of privacy violation because within a component, you can reference anything you want. So you create a kind of a boundary and everything inside that can be referenced. So this will be automatically kind of resolved, as well as anything we see nested under CI, like these ones, and pipelines as well. But there's some other ones that might not be like a good, might not be acceptable. So for example, if we look at the user app model user, and we do have CI pipeline. Yeah, CI pipeline is actually used as active record association. So a user has many pipelines. Yeah, that might be fine, but perhaps in such a complex application, we might want to start decoupling things. So maybe user doesn't not need to know about pipelines, but maybe pipelines can know about user. So we actually start to draw specific lines where we don't have like a circular dependencies, or we have like a one-way dependency, and we can start to decouple things. So maybe, for example, we could use this one to detect scenarios where we might want to decouple parts of the application. In this case, it will be about a matter of removing maybe this association. And say if you look user pipeline, it's actually used in 3 places. So this might be a good candidate to be removed or like inverted the dependency. For example, just pick one. So rather than being current user.pipelines, this could become maybe could be CI pipeline for user. So we invert this dependency, and by doing that, we actually can start to remove association from the user, and then eventually we can remove even this one, this entry, and slowly kind of work out this list by decoupling the code base. So this is like a way how we can leverage Packwork to guide us through what are the things that we have to look at in terms of breaking down the monolith. It doesn't mean we have to do exactly what Packwork, like to actually religiously resolve all these deprecations. Sometimes it's like a matter of making a decision. This is actually acceptable. We should keep this, or and there is several techniques we could use to decouple components. One could be this kind of inversion of dependencies, like we did here. In other cases, might be here, for example, we have this is another good example. So we use here user pipelines. But then within this user model, actually, we are running some CI code, and why the user needs to know about CI code. This is I'm just using Packwork to tell me whether there's something wrong with the design. And maybe this doesn't have to be done that way. So maybe this could be that this tells me when the user is blocked, then we should run some side effects. Maybe this could be event store publish. We publish an event that is user blocked event. We put some data here, like user ID. And we publish this event, and we could get rid of this completely because now we move that code into a subscriber. And now we actually remove like any knowledge of user from pipelines. And we could use this technique throughout the rest of the code base to actually understand where we can make some changes. I want to stop here for a second if there are any questions.
Oh, looks pretty good.
Thank you. Let me check in the doc if there is anything there. No. So yeah. So far, basically, what are the next steps on that? So at the moment, we've just been experimenting on how we can leverage packwork, but what's the next step in terms to how can we start using this within GitLab? One thing is we don't have to go through components like macro components, but we could say, okay, maybe there is some small parts like more like libraries or like gems are still living within the GitLab code base that we want to wrap around packages. So packwork also allows us to create like nested packages. So if I create a CI component, then within CI I can have like smaller packages that maybe are private to some parts of the CI. So not all CI knows about everything. So you can create this kind of packages or where we can have like a public methods or public classes that can be references, but anything else can remain private. And this could be used to isolate some small parts of the application. And this could be like one use case. And another one will be to do something like I demonstrated in this demo where we move some files. The rest of the CI code base is still in the main app folder, but slowly we move files into the CI component, and we can start to enforce things like privacy, dependency. Even if we actually don't do any of that, we still get some advantage by having an understanding of understanding of dependencies, but also all the CI code would be confined into a single folder. And that kind of allows already like kind of have some advantage in terms of scope, but also we can use that to clearly define ownership of code bases. Like this component is owned by these teams, and it's very clear. Like at least we know what is the part of the code base that doesn't have explicit ownership, and we can slowly close these gaps that way. But there's a lot of interesting things we could do with packwork. Like in a ideal world, when we have everything separated into components, like if something like merge requests is changed, and we know that the only thing that depends, based on this picture here, the only thing that depends on merge request is the web, then we only need to test merge request and the web component. If something changes in platform, the other way around, platform here called basically any utilities and anything that it needs, and kind of Rails boilerplate and base classes that need to be provided always for any components to work. But even we call like repositories, if something changes in repositories, then we know we have to test repositories, CI, merge requests, and web, basically anything that depends on repositories. And that allows us to optimize maybe CI to say we can actually, you don't need to test the entire application. We only need to test the parts that change and the parts that are affected by the change. And it's also clear for anybody who is making changes to an application to understand what are the implication of this change that I have. Well, today it's not very clear to understand, like, okay, I'm changing something in pipeline. Who knew that I would, maybe user could have been affected, as we saw in the demo. So yeah, I think this kind of basically a lot of advantages there, and I try to describe them all into the POC that you can also find linked, the POC and the proposal they can find linked in the presentation. But yeah.
Thanks, Fabio. Does anybody have any questions for Fabio? Discussion.
Is this the single source of truth for this work, the proposal, or is there like an architecture, like a blueprint or anything?
No, not yet. There's no architectural blueprint. It's actually part of the iteration plan to create an architectural blueprint. But this, yes, so that's basically it's currently this is the single source of truth.
Okay.
And the iteration plan is where defining what are the next steps. It could be like, in my opinion, we could probably start with a working group where we have representative of different GitLab stages, and understand basically how we can split the application in macro components. And that allows us to understand what are all these various areas that we have within GitLab, without even changing files. This could be like by listing all the files we have in the GitLab code base and put them in a spreadsheet and start categorizing that way. And with the help of all the engineers, and at least we understand how we could call these macro components, which is an exercise by itself quite useful, because it will help us to define the top level namespaces as we code. Today, like, we don't have clear guidelines on that. So even if we don't go all the way through splitting the monolith, this architecture exercise could be quite useful as well. Yeah. And then we can move it into architectural blueprint.
I've seen merge requests where people struggle to find where to put a new component, because they are inspired in something that already exists, which itself is not in a namespace. So yeah, it's hard to be the first one to do that.
Yes, exactly. And especially for top level namespaces, they should be like deep and not shallow namespaces. So in a way, like something like packages, where everything related to packages is within that, or CI is a good example. Maybe it would not be a good example to do something like maybe like I don't know, like approval, you know, approvals for merge requests. It wouldn't be like to be like the top level namespace. Maybe should be nested within merge requests component, which is like the kind of the macro component bounded context, and then within that, approval will be part of merge requests. It would not be like a top level namespace. And that kind of helps us identify, like, by looking even at the code base or an automatically generated diagram, that we could do it thanks to the YAML files that are generated, to actually generate like an entire GitLab code base diagram at macro components.
Yeah.
Okay, well, if there is nothing else, thanks Fabio, and thanks Pedro for the questions.
Yeah, thanks a lot, Fabio. It looks really interesting to finally have something that enforces this. Thank you.
And yeah, if you would like to follow along, there's some links for that, and any feedback. It's really helpful to understand how we think about the code base and what are the best practices that we can start applying. So yeah, anything will be super useful.
Thanks, everybody.
Thank you.
Thank you.
Bye.
Bye.